Hi there, I'm repairing some junk again. It's a HP 2810 48 port switch, and the problem here is that it reboots a couple of times per day, and when we look at the mainboard we can clearly see there are some bad capacitors inside, and I will show you today how to fix that. And it appears that the capacitor problem does not only affect cheap Chinese fake capacitors, but sometimes it's also with good brand quality capacitors, like in this case. I mean, this HP switch doesn't use any super cheap capacitors, but it runs 24 hours a day, and yeah, after about 8 or 10 years, that's about the age of that switch, some capacitors can fail, and well, you have to replace them. This indicator light guide here is a little bit tricky. You have to unscrew the tiny screw before you take out the mainboard. I did it the other way around, which is a little bit complicated. So if you want to remove the board, remove that screw first. The tools you need for that job is a good soldering station and a desoldering station with a vacuum pump to remove all the solder, to make it easy to remove the parts. So this time you see clearly which capacitors are bad, the one with the bulge on top. The other ones are still flat, so I leave them in place, but you don't have a guarantee that they are actually okay, so I will test that and we will see. In addition to the desoldering station, I also use a hot air gun. That makes it a bit easier to melt the solder, especially when you have a multi-layer board with large ground planes and stuff. You will see how I use it. One problem here is that the original solder is a lead-free solder, and that has a little bit higher, needs a little bit higher temperature to melt. So I remove as much as possible of that lead-free solder, replace it with some normal lead solder, and when the lead solder is going through the hole, it's much easier to remove it after that with the desoldering iron. So that's what I'm doing right now. Adding some fresh solder with lead, and that makes it easy to melt through the other side. So the whole problem here is to get the heat through the board to the other side, because the solder is through that hole from one side to the other, and you have to melt that completely, and that's always a little bit tricky. You see that I go in circles with the desoldering tool. I do not apply any pressure down to the board because that would damage the board. I only go in circles to make sure to get all the solder out around the lead of the component and also from that hole. And you can also see how the component starts to wiggle around when all the solder is removed or molten, and then you start the pump to suck everything out. So that's how I do it, and I think that works best. And of course, sometimes you have to repeat that step with the leaded solder because you probably don't get all the unleaded solder out. So you put some fresh solder in again, and that mixes with the original solder, and maybe after 2-3 times the component will finally fall out by itself, as you can see here. It is also important to have a solder tip or a desoldering tip that is clean and straight on the tip, because if it has cracks or anything, it will damage the board when you move it across the board. So if you have an old tip, so you better take a new one if you don't want to damage the board. And sometimes, of course, it happens that the holes are not entirely cleared from the solder, so we do just the same thing again. We fill it up with leaded solder and remove that solder again, and if necessary we repeat that step until the hole is fully cleared and we can insert a new component. The whole trick here is to get the right timing. You need to wait until the heat goes from the side where you're working to the other side of the board, so that takes time. So if it looks like I'm hesitating or something, that's on purpose, because I have to wait until the solder has melted. So it's time to select some new capacitors. We have of course some capacitors here in the drawer. Unfortunately they are a little bit taller than the originals, but it shouldn't be a problem because there is enough space in the case of the switch, and I will check if they fit. Okay, let's see, they have about the same height as the other ones, clearing Yes, that should fit, no problem. Always check the polarity. Here on this board it's easy. Positive, negative is clearly marked. There are some mainboards that have no markings on top, so be careful when you remove the capacitors. If there are no markings, make your own markings with a waterproof marker and whatever. I once made the mistake to remove all the capacitors and then realized there are no markings, and it's a bit a problem to find out which way round they go. After placing the capacitors, I bent the wires a little bit. I pull them and bend them to the side. That makes the capacitors stay upright and straight, and it also prevents them falling out when I'm soldering. And that's how it should look before soldering. All capacitors straight, not in an angle, nothing. Then I'm setting my soldering iron to maximum temperature, 450 degrees in this case, and I also use the widest tip that I have, because you need all the heat you can get to get the solder through the hole to the other side. But to make soldering a bit easier, I use a fine soldering wire. So I use a large tip but a fine wire, and that makes it easy to get the right amount of solder for that job. You may also notice that I remove the soldering iron upwards along the wire of the component, because when you take the soldering iron away, you will always create some kind of nose, some kind of tear, and if that tear sticks to the wire, it will cut away after soldering anyway, so the soldering spot looks a little bit nicer like that. And when cutting the wires, don't cut it too close to the board. Leave maybe 1/4 of a millimeter of the wire stick out of the solder, and also do not cut the solder itself, so that makes it look a little bit nicer and more stable. Sometimes after the cut of the wires, I re-solder the solder spots again to make a really nice looking solder. So normally it's not necessary because nobody looks inside that device, but here for the video I do that, and you will see the result right after that. Then if you want a really clean job, you can use some alcohol to clean the soldering spots again, to remove all the flux that has spread over the board. Yeah, but normally I don't do that because I don't have the time for all this and it's not really necessary, but here for the video I will show you how that works. Well, at the end that's probably not the prettiest soldering spots, but well, the board was quite difficult, so the best you can do here. And these capacitors are okay, but there are a couple of more I would like to change, especially the small ones here. And it seems in this corner of the board they have a little bit smaller ground planes or different board layouts, so they are much easier to remove than the others. And here you can see again from the other side what I'm doing with the leads. I'm pulling them and bending them to the side so the capacitor will stay upright and straight, and it will not move while I'm soldering, and that's all it needs. Then again, soldering them in with the large tip, high temperature, and a small diameter soldering wire. And you can see how the solder goes down the drilling hole. And yeah, if it looks like that, it's a well done job. It's difficult to get it any better on these boards, and well, it works, and that's the most important thing. And here's that stupid light guide, which I struggled when I removed the board. It guides the light from the LEDs to the front panel. And the little screw of that light guide has to be removed before removing that board. So now when I'm installing the board, I will install that screw after the board is in, so that makes everything a little bit easier. It also seems that you can't get the board in without removing the first fan here. Interestingly, I got it out, but I probably was bending the board a little bit, and that way it went. But installing it is not possible without removing the fan, but that's an easy thing. There are 2 screws and that's it. And then I'm putting the screws back in, and a little trick here: don't tighten the screws until you have all the screws in place, because sometimes you need to move the board a little bit to make the holes clear for the other screws, and if you tighten the first screw you can't move the board anymore. So first you just put the screws in loose, and then when all the screws are set, you tighten them up all together. Okay then, let's see if that thing is still working. I mean, it was working before, but it rebooted from time to time because of the bad capacitors. And now it should work like new. Let's see if it actually does. So I'm connecting the serial console port. That's an RJ45 connector, but it's a serial RS232 signal that comes out, goes to that server, to the COM port 1, and I use my adapter board here, my diagnostic and universal serial cable that fits to everything. And with this switch I can select a crossed or a straight cable. If two green lights are on, everything is working correctly, or at least the cable is correct. Then you still have to know the correct speed, and hello, that's me. It's a stupid screen with a glossy finish on top. I don't know why they make that, especially for a console screen, but yeah, that's it. And you see, switch is booting. You can see this switch here has automatic speed sense. You press enter 2 times and it adapts automatically to the settings you have on your terminal program. I use PWJ for that purpose. And then I just go into the setup menu of the switch, and if the switch should reboot, I can see that it is no longer in the menu but on the login again, and then I know it has rebooted, or hopefully it doesn't do that anymore because I changed the capacitors and everything should be okay. So, thanks for watching. See you next time.